Okay, in lesson 73, we are going to just look at a few more problems with radicals in the denominator. And remember that it's fine to have radicals in the numerator of a rational expression, but it's not okay to have them in the denominator. And we learned that if you have a denominator that is a binomial expression with two terms, then you will have to use the conjugate of that denominator in order to get rid of those radicals. So 4 plus 3 square root of 2 would have a conjugate of 4 minus 3 square root of 2. We can't change the value of this expression, but we can change what it looks like. And so we're going to multiply the numerator and denominator by the conjugate of the denominator, and we're going to use the distributive property to multiply all that out. And you can see on the bottom there that when you multiply conjugates, you're going to get the first thing squared, so 4 squared, minus the second thing squared. And the second thing is 3 square root of 2. And so that will be squared. So now you will get a difference of squares in your denominator, which will make those radicals be completely gone. And you can see that there is a factor of -2 in the numerator and in the denominator. So if you simplify that fraction, you'll have -11 plus 8 square root of 2. All right, here's another one. It's very similar, just looks a little more complicated. It has more radicals in it. So the first thing I'm going to do is simplify that square root of 12, because that is not a simplified radical, and I think it'll be just easier to do that first before doing anything else. So if I do that, I'm going to have 3 times the square root of 3 times the square root of 4. And when I simplify that, I will get 6 square root of 3 there. And now I can just add 6 square root of 3 minus 2 square root of 3, and I'll have 4 square root of 3 in the numerator. So that's a lot simpler than having that binomial up there. Now I can multiply the numerator and denominator by the conjugate of the denominator, which would be 3 square root of 3 plus 2 square root of 2. And now I'm just going to distribute. So we end up with 36 plus 8 square root of 6 in the numerator, and then in the denominator, it's going to be first thing squared, which is 27, minus second thing squared, which is 8. So we end up with 36 plus 8 square root of 6 over 19. Okay, now we're going to look at some more uniform motion problems where both distances are given this time. We have done lots of uniform motion problems, and first we started out with problems where the distances were equal. So rate times time for one person was equal to the rate times time for the other person. Then we did some where the distances added up to some number that we knew, like if two people were far apart and they drove until they met in the middle, you had two people starting in the same place and driving away from each other so that we knew how far apart they were. So those are the kinds of problems where we knew the sum of the distances. And then sometimes you had a difference of the distances, and that was when you had someone with a head start. So now we're going to look at problems where they totally give you the distances. They tell you exactly what the distances are. So Nick ran 4 times as fast as Angela. In fact, he ran 80 miles in 2 hours less than it took Angela to run 28 miles. How fast did each of them run? How long did they run? So we're going to set up our chart with Nick and Angela, and rate times time equals distance. First thing they tell us is that Nick ran 4 times as fast as Angela. So if we call Angela's rate R, then Nick's rate will be 4 times R. And then, okay, now we're going to look at their distances. It says he ran 80 miles and she ran 28 miles. So we'll just go ahead and fill those in. And then it tells us that his time, he ran 80 miles in 2 hours less than it took her. So his time is 2 less than hers. So if her time is t, his time is going to be t minus 2. So we have all our information organized in the chart, and now we can write our equations. So rate times time equals distance. 4r times t minus 2 is 80, and rt is equal to 28. We can use the distributive property to multiply that first equation out. So we'll have 4rt minus 8r is equal to 80. And then the second equation we can just use that second equation and substitute it into the first equation for RT. So wherever I see an RT, I'm going to put a 28. And so I'll have 4 times 28 minus 8R equals 80. And then if I multiply that out, I get 112 minus 8R equals 80. Subtract 112 on both sides, and you get that negative 8R is equal to negative 32. So R is 4 miles per hour. So is that what we're looking for? And the question actually asks us how fast did each of them run? So yes, we do want to know that. And how long did they run? So we're supposed to give the rate and times for each of them. So we know Angela's rate is 4 miles per hour. We know that Nick ran 4 times as fast as she did, so his is 16. We know that since her rate is 4 and her distance is 28, that means her time was 7 hours. And we know that his distance is 80 and he's going 16 miles per hour, so his time would be 5 hours. All right, in lesson 75, we are going to look at something we've already looked at, but just a slight difference. And that is that sometimes, remember, we can make a sign change in our denominator of one of our fractions if we're adding two rational expressions to get a common denominator, because the denominators are just opposites. So you can see that x minus 5 and 5 minus x are opposites. They're not conjugates, they're opposites. X, negative 5, 5. They're opposites. So remember that if we want to, we can change this to 3x plus 2 over x minus 5 minus the opposite of x minus 3 over 5 minus x. And then if we distribute that negative sign through the denominator of the second expression, we'll have minus x minus 3 over negative 5 plus x, which is x minus 5. And now we can just add that up. Remember to use the distributive property with this minus sign right here. You have to distribute it minus x plus 3, and that's all over x minus 5, which is going to be 2x plus 5 over x minus 5. And please remember that you can't cancel the 5s. They are not factors. You can only cancel factors in a fraction. All right, so now we're going to do some more like this, except now there'll be some factoring involved, and there may be other factors, not just two opposites, but there might be another factor as well. So we're going to factor this denominator. So we'll have x plus 3 over x minus 3, x plus 2, and then over here we have this. Now, we have a factor of x minus 3 in this one and a factor of 3 minus x in this one. Those are opposites. We will go ahead and distribute this minus sign into the denominator of the second expression, and that way it will be x minus 3. So we'll have one factor ready to go in our common denominator. So x plus 3 over x minus 3 times x plus 2 plus 3 over the opposite of 3 minus x, which is x minus 3. So now to get a common denominator, all we need to do is multiply that second fraction by x plus 2 over x plus 2. And when we do that, we will have a common denominator. So x plus 3 plus, remember to distribute here, 3x plus 6 all over x minus 3 times x plus 2. And that's going to give us 4x plus 9 over x minus 3 times x plus 2. Okay, here's another one. We're going to factor this again. We'll have x plus 7 over x plus 1 times x plus 1. And then we have a minus 3 over negative 1 minus x. If we distribute this minus sign through the denominator, we will have x plus 1 in that denominator as well. So we'll have plus 3 over x plus 1. And now all we need to do is multiply this second fraction by x plus 1 over x plus 1, and we'll have a common denominator because they will both have the denominator x plus 1 times x plus 1. So now we just add the numerators. So x plus 7 plus, distribute the 3, 3x plus 3 all over x plus 1 squared. And so this is going to be 4x plus 10 over x plus 1 quantity squared. We'll factor that denominator. And we can see that that second denominator is the opposite of x minus 5. So we can change this to minus. We'll still have x plus 2 in the numerator, but in the denominator, we'll have x minus 5. So all we need to do is multiply the second expression by x plus 3 over x plus 3, and we'll have our common denominator. So x minus 3 all over x minus 5 times x plus 3. And remember that you have to think of this, you have to think of the fraction as having parentheses around it, because you will need to multiply the whole numerator by x plus 3 and the whole denominator by x minus 5. So, and also this minus sign is going to have to be distributed as well. So what I'm going to do is go ahead and put that minus sign, and then I'm just going to do all this multiplication right here before I distribute that minus sign. So I'll have x squared plus 3x plus 2x plus 6. And so then I will have to add all that up. So x minus 3 minus x squared minus 3x minus 2x minus 6 all over x minus 5 times x plus 3. And once I add all that up, I'm going to have x squared minus 4x minus 9 all over x minus 5 times x plus 3. And I would have expected that if I factor that numerator, there might be something I could cancel, but that numerator actually does not factor. So I would still, if you're doing a problem like this and you end up with a quadratic in the numerator, check and see if you factor that, can you cancel one of the factors in the denominator. But in this case, that's not going to happen.